Thank you for joining us this evening as we welcome Brother Guy Consolmagno. It's good to be back home at Immaculate Conception after having been away for some time. Our kitchen renovation project is complete, during which time our commons was a complete mess. But as we begin this evening, let us do so in prayer. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Good and gracious God, we thank you for this opportunity to come together as a church and explore our faith and lives more deeply. As we enter into this experience tonight, open our minds and hearts to what we will hear. May tonight guide us to a better understanding of our faith. And we ask this through Christ our Lord. Amen. Amen. Father, Son, Holy Spirit. Amen. The format this evening will consist of a presentation by Brother Guy, followed by a period of questions and answers. You can submit a question using your smartphone at any time tonight. Just open your browser and visit KeaneInstitute.org. And on the home page, just press the button that reads Ask Brother Guy a Question. A form will pop up, enter your question, and hit Submit. The information is also on the front of your program. We will also be collecting questions using the note cards that were on your seats when you arrived. Please feel free to write a question on those cards, and we will pass baskets at around 8:15 p.m. to collect the questions. Brother Guy will not stop his presentation, but will simply keep going, so when the baskets begin to pass, it is for your questions. It's not this evening's collection. But I guarantee you that we will ask your question if you staple a $20 bill to your note card. So, as is our practice, we will conclude tonight around 9 o'clock. Before I introduce Brother Guy, though, a brief word on the Bishop Keane Institute. It was inaugurated in 2015. The Institute, it takes its name from the 5th Bishop of Richmond and the founding rector of the Catholic University of America, John J. Keane. Bishop Keane embodied a profound commitment to education, to faith-seeking understanding, and he worked tirelessly to provide those opportunities at every level for children, university students, the laity, and his priests. Bishop Keane's commitment to Christ revealed itself in his truly Catholic worldview that the experience of Christ leads us to engage with the world and its needs in every place and every time. The mission of the Bishop Keane Institute is to further that relationship with Christ and the commitment to the world that flows from it, and our primary effort, the Bishop Keane Institute Lecture Series, brings the leading voices in Catholic and soon ecumenical thought, ministry, and education to Hampton as a way of engaging and energizing our community in Hampton Roads to participate fully in the mission of Christ Church. In 2015, we had an immensely successful first inaugural year. I know that's the same thing, but anyway. We had nearly 3,500 people attend one of our 4 events last year, and as of right now, we have over 1,100 people that are a part of our email newsletter as subscribers. The 2016 year is underway, as you will notice also on the back of your program, and we are about to finalize the 2017 series. We're in conversations for 2018, and we've already begun the process of looking at 2019. Joining us this evening is a man whom we believe embodies the spirit of the Bishop Keane Institute, Brother Guy Consolmagno. Brother Guy is an astronomer and curator of meteorites at the Vatican Observatory. A native of Detroit, Michigan, he attended a Jesuit high school and went on to earn his undergraduate and master's degrees from MIT and a PhD in Planetary Science from the University of Arizona. He was a postdoctoral research fellow at Harvard and MIT and taught university physics at Lafayette College before entering the Jesuits in 1989. In addition, he served in the United States Peace Corps, serving in Kenya. At the Vatican Observatory since 1993, his research explores connections between meteorites, asteroids, and the evolution of small solar system bodies, and applying his measure of meteorite physical properties to understanding asteroid origins and structures. Along with more than 200 scientific publications, He is the author of a number of popular books, including Turn Left at Orion, Brother Astronomer, God's Mechanics, and Would You Baptize an Extraterrestrial? Two of his works are on sale in the Commons after tonight's presentation, and Brother Guy will be available at a table to sign books after this evening's presentation. Brother Guy has hosted science programs on BBC Radio 4. He's been interviewed in numerous documentary films and writes a monthly science column for the British Catholic magazine, The Tablet. Brother Guy's work has taken him to every continent on Earth. For example, in 1996, he spent 6 weeks collecting meteorites from a NASA team on the blue ice regions of East Antarctica. He served on the governing boards of the Meteorite Society, the American Astronomical Society Division for Planetary Sciences, of which he was once the past chair, and in 2000, the Small Bodies Nomenclature Committee of the International Astronomical Union, IAU as it is referred, named an asteroid 4597 Consolmagno in recognition of his work. And in 2014, he was the first clergyman to receive the prestigious Carl Sagan Medal from the American Astronomical Society Division for Planetary Sciences for excellence in public communication in planetary sciences. And more recently, in 2015, Pope Francis appointed Brother Guy as the director of the Vatican Observatory in Rome. When Brother Guy found out that he won the Carl Sagan Award, he said in an interview with the Detroit Free Press, quote, "I'm embarrassed to admit just how pumped up I am to have been given that award. It really means a lot to me. I remember how his," referring to Carl Sagan's, "enthusiasm and sense of humor helped him communicate the excitement of what we were doing in science. I've always tried to imitate that." Tonight, Brother Guy will speak with us on the heavens proclaim, astronomy, and the Vatican. In fact, the roots of the Vatican Observatory go back to the Gregorian Reform of the calendar in 1582, and it has been part of an extensive history of church support for astronomy. Its modern mission for the last 100 years, is to show there is no inherent conflict between science and religion by simply being people supported by the church whose sole mission is to do good science. Tonight we are honored to have Brother Guy with us as we embark on an evening of the world out there, beyond the sky we see each day and night, and do so while too exploring science and faith. Ladies and gentlemen, Brother Guy Consolmagno.
Thank you. Wow. I have to say that everything I want to say is said simply by me being here, wearing a Roman collar and an MIT ring. This is an MIT ring. There was a time I was at a party in Rome when somebody came up and tried to kiss it. It's proof that you can at the same time be a fanatic and a nerd. I am a fanatic about my science. I'm really passionate about it, and something of a nerd about my church. The Vatican Observatory itself is something that people have questions about, and we'll get to a sort of a history behind it. But I thought to give you an idea right now of what the observatory is, rather than me coming up here and talking to you, I'd turn it over to somebody on a short video who can explain it far better than I can. Both science and religion are conversations about the universe. They're ways of learning how we interact with this universe. It's not simply a question of, is there a God, but there is a God, now what do we do? It's not just a question of, there are a bunch of stars, but rather, why are there stars? How do they work? How does that tell us how things work here on Earth? The interaction that I see in my own life is that religion gives me the reason to do the science.
Back in the papacy before Francis was Benedict, and one of his lines in a final elocution to the fathers of the General Congregation was, "Go to the frontiers. Well, there isn't much more frontier than 3.7 billion years away.
The first official interest of the Church for astronomy started in 1582 with the reform of the calendar. Then in 1891, Pope Leo XIII wanted to have an observatory to show that the Church is not against science, but the Church promotes good science.
They start out by having telescopes on the Tower of the Winds, and then on the walls surrounding the Vatican. As the city lights grow, and as the Italian government gives them back the territory out in Castel Gandolfo, in the 30s they build new telescopes on the roof of the Papal Palace in Castel Gandolfo, best telescopes of their era in the 1930s. By the 1980s, light pollution makes those telescopes unusable, so we build a new telescope in the dark skies of Arizona.
I'm Father Jean-Baptiste Kikwaya Eluo. I'm working in 3 projects. The first one is NEOS, Near Earth Object. So what I'm doing with NEOS is just observe them using our modern telescope VAT. The second project is meteors. I worked on very faint meteors, what we call shooting stars. And the third project is set fireball network. They will have 4 cameras here around Tucson so that actually we can monitor any fireball getting into the Earth atmosphere in the region.
This telescope, the Vatican Advanced Technology Telescope, it was the first of the new technology telescopes that has been considered pretty much the norm now in developing telescopes. With the advance of computer technology, we have the capability of bringing that advanced technology directly into our telescope. So it's an expandable, it's almost like it's a living machine, so it can grow as technology grows.
It is still very important to maintain scientific research at the Vatican, simply because there is still a lot of confusion about this relationship between science and faith. We are not out here trying to prove the existence of God by looking through a telescope. That's not what we're doing. But we can say that if we want to obtain any reasonable results looking through that telescope, we need to do it embracing a certain work ethics that is, in fact, the same work ethics that the Bible itself tells us through commandments and through the Gospels to embrace.
Human beings look at the stars and wonder. They want to know, what is that? What is that about? How do I fit in? They hear about the moon landing and they want to know, what was that like?
Very well.
If we're part of the human race, we're part of the race that went to the moon. We're part of the species that looked at the stars and wondered, what the heck are those things? Looking at the sky reminds you that there's more to the universe than what's for lunch. What's more, if you believe in a universe that God so loved that he sent his son, then not only are you going to want to study the universe because it's kind of cool, it's an act of worship. It's an act of getting closer to the Creator and getting closer to a universe, as St. Athanasius said 1,500 years ago, was cleansed and quickened by the Incarnation. Then, doing science is an act of worship. A question I get a lot is, does my science prove the existence of God? To my mind, that question is exactly backwards. If science could prove or disprove God, that would make science bigger than God. And any God that could be proved by science is not a God I'd want to believe in. It works the other way around. My belief in God gives me the courage to do science. You have to remember that we didn't always do science. We didn't always have a scientific belief. We didn't always have courage that there were laws to be found, much less laws to be found that we could find. Every logical system, science is a logical system, every logical system starts with axioms, starts with things that you have to accept on faith before you can do the rest of the logic. Whether it's Euclid, who had the 18 axioms that allowed you to do Euclidean geometry, 17 were obvious and one was not at all obvious, but without it, you can't do anything. And if you change that last one, then you have Riemannian and other sorts of interesting mathematics. Every kind of system starts with an axiom, and those axioms, I maintain, for science, involve religious beliefs. Religious beliefs because there are some religions that don't accept those axioms. So, for instance, if you're going to believe in science, that science is possible, you have to believe that there actually is a real universe that you're studying. Unless you're doing quantum physics, but that's a different issue. If you're, the famous story of the Zen philosopher who woke up from a dream and could not decide, am I a Zen philosopher who dreamed I was a butterfly, or am I a butterfly who's dreaming I'm a Zen philosopher? You can't answer that rationally. Either could be true. You have to accept as a kind of religious faith. The real world reality exists, regardless of how poorly I understand what that reality is. You have to believe that the universe follows laws. It's not just random chance. More than that, things that happen in the universe don't happen because some nature deity made them happen. If you're living in ancient Rome and you see a lightning bolt and you ask the wise man, why did the lightning bolt strike? The answer is, Jupiter, the god of lightning, threw the bolt. And there's no way that you can scientifically disprove that. If you're asking, why do crops grow? Why is it that your apple tree is giving great apples and mine isn't? It's because the goddess of apple trees likes you better than me. It has nothing to do with fertilizer or anything else. If that's the way you approach the universe, you've got a wonderfully coherent worldview that I cannot disprove. But if the world is explained by nature deities, then there's no room for a God. And there's also no room for science. What do I mean by no room for a God? I'll get to that. Because you see, only when Judaism and Christianity and Islam insisted there's but one God, and that God is supernatural, and there are no other gods, well, by golly, at that point, the Romans said, you're a bunch of atheists. You don't believe in our gods. And they were right. People, sometimes say, all scientists are atheists. That's almost true. To be an atheist, you have to have a great idea of what the God is that you don't believe in. And most of those visions of God, I don't believe in either. I don't believe in the gods of nature. I don't believe in Zeus or Jupiter throwing lightning bolts. I don't believe in Ceres causing crops to grow. Compared to Stephen Hawking, we're practically neighbors. I only believe in one more God than he does. But it's only by removing the nature gods that I have room to then ask, okay, if there isn't a Zeus throwing lightning bolts, then why is there lightning? The last and the most controversial belief, but it is a religious belief, is to say that the physical universe is worth my time and effort to study. And what's more, it's worth the time and effort of the rest of you people to let me study it. And not just that you'll pay for it, but that you won't make fun of me or you won't criticize me because I'm not doing better things with my life. Ask a funding committee from Congress. You see how hard it is to convince people that doing science just for its own sake is worthwhile. I don't do astronomy in order to get rich. Trust me, it doesn't work. I don't do astronomy to become powerful. I didn't become an astronomer when I was in college to get girls. That didn't work either. Why do I do astronomy? Because I believe the universe is good. Where did I get that idea? Not every religion believes the universe is good. There are religions that say the physical universe is a series of traps, a series of temptations. Chocolate is the invention of the devil to lure you into perfidy and overweightness. But I believe something different. Chocolate is a sign of God's love for me. A God who would make a universe with chocolate in it, obviously has something good going on. More to the point, my basic scripture says that God created the universe. What does Genesis say? Number one, that God created the universe. Number 0, that in the beginning, before there was a universe, there is a God. So God is not part of the universe. God is not a creature. God does not exist in space and time, but rather outside of space and time. God is supernatural. And by supernatural, I don't mean ghosts and goofy things like that. Because if you could prove to me that ghosts exist, then that would be a part of nature. They would only be natural. They would not be supernatural. And this supernatural God doesn't create the universe by mistake, the way the Babylonian gods did. When you read the Babylonian stories, remember Genesis was written by a Jewish people in exile fighting the misconceptions of the universe that the Babylonians were teaching. And so they said, all right, we'll take the best science of the day, Babylonian science, but this is how it really happened. It's not how the world is put together, it's who did it. That's the new and important part of Genesis. And that's why Genesis chapter 1 gives a very different story from Genesis chapter 2, which gives a very different story from creation that you get in the book of Job, which is a very different story from creation that you get in the Psalms, which is different from what you get in the book of Baruch, which is different from what you get in 2nd Maccabees. All of these are creation stories. All of them are different in terms of the nuts and bolts and the science of how it was done, but all of them have the same story. That God made the universe on purpose, looked at it, and every step of the way said, this is good stuff. So that we can go to the New Testament and the words of St. Paul, who tells us in the opening chapter of Paul's letter to the Romans, since the beginning of time, God has revealed himself in the things he has created. And that's why doing science is an act of worship. That's why the medieval church started what we call science in the universities. Before you could go on to study the highfalutin stuff of theology and philosophy, you had to first take the trivial courses, the trivium, grammar, rhetoric, and dialectic. In other words, how do you talk? How do you express yourself? How do you communicate? And then you had to take the quadrivium, the 4 courses that teach you how to handle the data of the universe, arithmetic, geometry, astronomy, and music, all of which are very mathematical at their basis. Only then can you go on to do what really the goal of all science is, or the goal of all education is, which is either theology or philosophy. That was the medieval view. Of course, nowadays, universities are set up to teach you many other things, and you wind up your ultimate degree being not a degree in, well, you don't get people with degrees in Doctor of Philosophy, never mind. We still have this same system. This is the university system that still educates us so that we've got the grammar school of grammar, rhetoric, and dialectic. We've got the high school of the quadrivium, and we've got the universities leading on to a philosophy degree. Astronomy in particular was important also because astronomy allows us to make calendars, and calendars allow us to not only have commerce, but also have a common time to celebrate the important feasts that remind us of when God had interaction with the human race. So in 1582, in order to make sure that Easter didn't slide off into the wrong season, Pope Gregory XIII hired a bunch of astronomers, including the Jesuit Christopher Clavius. And Clavius explains in the 1603 book, which was our copy at the Vatican Observatory, he explains how we're going to do calendars from now on. The funny thing is, after looking at the astronomy, they decide not to use astronomy. What is Easter supposed to be? Fundamentally, Easter is the Sunday after Passover. What is Passover? Passover is the first full moon of spring. What is spring? Spring is the moment when the day and the nighttime are of equal length and the daytime is growing and the nighttime is shrinking. But how do you calculate that? And what happens if Passover occurs on a Sunday? And what happens if Passover occurs on a day that's a Sunday in one part of the world but a Saturday in a different part of the world? And how are you going to calculate this out so you can figure out a couple of years ahead of time when Easter is going to be? They had good enough astronomy by then to know that the problem wasn't as trivial as it looked. By the 1500s, people were living far enough away from each other so that it could well be Saturday in one part of the world and Sunday in a different part of the world when the moon was full. The final decision in the Gregorian Reform of the calendar was to come up with a totally arbitrary mathematical formula that recreated roughly the idea of the Sunday after Passover. In a century, it might get it wrong 10 times, 90% accuracy. Pretty good if you're a baseball player, but otherwise. The deeper philosophical principle is that we, as Christians, are not tied to the position of the moon to determine when our celebrations are going to be. The Sabbath was made for man, not man for the Sabbath. And we are free to arbitrarily say, this is when we're going to have Easter. Everybody, let's have Easter at the same time. Rather than trying to, well, I don't know if they're, and worrying about the details of, which in other words, we can have Easter when we go to the moon. We can have Easter when we go to Mars. We could have Easter even if there was an explosion on the far side of the moon and it goes hurtling off into space, creating terrible TV programs. An interesting philosophical idea that came out of our understanding of astronomy. Very practical one. So that with this calendar in the book, Clavius can come up with a list of years up to the year 5000. And he tells you when Easter is going to be. This is 2016. Easter is going to be on the 27th of March. Ash Wednesday was the 10th of February. It's a formula. It's pretty darn good. If you go up 3 lines, you'll see there's a typo and he got it wrong, but never mind that. The reform of the calendar, of course, was a big shift in the way people understood themselves and how they dealt in nature. It was, a shocking thing to do. There was a need to demonstrate to people that we knew what we were doing. At the Vatican, that little tower, which is now above the Vatican Library, that's what it looks like from the ground looking up. It's called the Tower of the Winds because a painter in the 1500s painted the different winds on the 4 walls. But on the south wall, there's this little angel with a hole. The hole actually allows sunlight to pour through. It acts like a pinhole camera. And day by day, you can see where the spot of sunlight crosses the center line, the meridian. As the seasons progress, the sun gets higher when it's summertime, lower in wintertime. You can map out the 2 extremes, and the midpoint is going to be the first day of spring or the first day of fall. And you can demonstrate that our calendars were 10 days off, and needed fixing. This was not the device used to calculate, like some people say. This was actually built and opened in 1582, but it was a device used to demonstrate the needs for the calendar. And it's not only in this tower in the Vatican that they had it. Pretty soon, every major church had a little hole in the south wall that leaves a spot. This is in the cathedral in Bologna. Cassini, a great Italian or French, he was born in the border and both countries claim him, but a great astronomer, went through Europe, especially in Italy and France, building these devices, number one, to demonstrate to people why the calendar worked. Number two, because these big cathedrals allowed a really big image of the sun by the time that spot hits the ground. You can actually, in some of these, see sunspot groupings. It's just like a big pinhole camera. What he was hoping to be able to do was to measure the size of the spot as it got bigger or smaller to test whether Kepler's theory of orbits actually fit the data. The trouble is, they didn't know at the time, the wave nature of light means you never get a perfectly sharp edge, and the size change is too tiny for them to actually come up with a definitive answer. What he also could do with these, of course, was to work out with timing the exact latitude and longitude of each cathedral. He did this for all the major churches in France, presented the first accurate map of France to the King of France, who then said, "Thanks. Thanks to your map, I've lost more territory than I've lost in all of my wars." Likewise, during that same 17th century, the Jesuit Riccioli of the Society of Jesus, writing 20 years after the infamous Galileo trial. I didn't mention Galileo. Let me just say this about Galileo. First of all, everything you know about Galileo is wrong. Number two, when you know the truth, it does not make the church look any better. But the mistake they made isn't the mistake that everyone accuses him of making. Galileo was irritating, a plagiarist, a nasty to his friends, deeply beloved by his friends, utterly brilliant, not in discovering things, but in being able to understand what he had discovered. And if he was irritating and nasty, well, so are most scientists that I know today. Nothing new there. He was a good Catholic. His two daughters were nuns. Of course, he never married their mom, but he was an Italian Catholic. And he's somebody that we as Catholics and I as an Italo-American is somebody we can be proud of. For all of his faults and failures, he did what the church asked him to do, even when they were wrong to ask him to do it. And he could have fled to the north, and he didn't. He's a great man. But there were good scientific reasons why people didn't accept his theory. Given what they knew at the time, I probably would not have been a Copernican. It didn't match the data of the day. It just turned out to be a beautifully elegant way of looking at the universe that eventually we understood how you can make it fit the data. Riccioli, writing in 1651, 20 years later, lines up all the arguments for and against the Copernican system. But among the other things he does, he makes a beautiful telescopic map of the moon with the names of craters that we still use to this day. And the most prominent crater on the moon, he names Crater Copernicus. Because even when people were disagreeing about whether or not this was the best science, or whether or not this theory of the Earth moving around the sun violated what some people said Scripture said, they all recognized that Copernicus, another great Catholic, was someone to be honored in the world of astronomy. And in this map, Riccioli also has other craters named for people who believed in the Copernican system nearby. So there's the Greek Aristarchus, there's Kepler, there's Galileo, and there is him himself. By the end of the 17th century, we finally had enough understanding of physics, thanks to Isaac Newton, that the Copernican system finally made sense and was widely understood to be correct by the end of the 17th century, and it was taught in the Catholic schools, to the point where the Jesuits were getting into trouble for teaching it, so they would teach it, well, this is a great way to measure where estimate where the stars are going to be. And they started working on the people at the Vatican so that by 1750, not only was the Vatican able to announce, yes, you can teach this system. We still won't let you actually teach the Galileo book because we don't want to admit we were wrong, but yeah, you can teach any book that talks about it. By 1755, this is the ceiling of the Jesuit math library in Prague. And you notice that every star is surrounded by planets. Just as the same angels who before had holes in their mouth for light to go through, now they've got little telescopes to observe the skies. The idea that the church was somehow opposed to science during this era can be easily disproved. You go to any collection of scientific works and you ask, who were the scientists? What does it take to be a scientist? You got to have an education. You got to have the free time to do it. And you have to have the interest in the physical universe. Who in those days had the education and the free time and maybe the interest? Wealthy people, noblemen, and clergymen. So that I went to our collection of the Philosophical Transactions, which is just sitting on a shelf in the library at Castel Gandolfo. And this was the first book I pulled out, and I pulled out at random the table of contents. Who are the people writing articles in 1735 and 1736? This is the Philosophical Transactions for July, August, and September 1736. There's a medical doctor. There's a nobleman. There is a German who's just listed as the Fellow of the Royal Society. There's a sea captain talking about the magnetic fields in Hudson's Bay. And there's the Reverend, who also happens to be a doctor of law, and another nobleman. And that's pretty much typical. What is science? And a day-to-day, moment-to-moment, what's the work you do? We got scientists in this room, I suspect, and engineers. Show of hands, how many people working in science? Day to day, what's the piece of software you're more likely to be using than anything else? Maybe a spreadsheet? Science is taking data, writing it down on little 3x5 cards back in those days, sorting and filing the data, trying to make sense out of this put of data looks different from that put of data. You know, you run it through the card readers back in the days before we had computers. What do we call the task of writing down data and sorting and filing data? It's clerical work, right? Why is it called clerical? The word clerk comes from the word cleric. And what is the typical task of a parish priest? Keeping track of births and deaths and marriages and who got married to whom. And that is your first cousin you're engaged to, you realize. That's the task, that's the logic, that's the technique that is used in sorting and filing and making sense of scientific data. And it was done by clergymen. In 1761, when astronomers wanted to measure the transit of Venus, Venus, twice every 120 years, can be seen to cross the face of the sun. Really, really interesting observation, because if my head is the sun and my fist here is Venus, as it crosses in front, the people in the back row are going to see it cross in front of a different part of my face than the people in the front row. And by comparing the difference in the length that you in the back row see from you in the front row, compared to the distance apart from those two people, you can build triangles. And everything with triangles leads you to surveying, allows you to actually measure the number of kilometers from here to Venus compared to the number of kilometers from the different places. They sent people all around the world. Captain Cook went to the South Seas to carry people to measure the transit of Venus. Mason and Dixon came to the Americas to measure the transit of Venus. That's why they had a surveyor and an astronomer, in this part of the world. 25% of all of the observatories in Europe, Jesuits observed the transit from Sweden. It was illegal for a Jesuit to set foot in Sweden in those days because the Protestants in Sweden were so terrified that the Jesuits would do horrible things like convert them. Nonetheless, because they were such good astronomers, the King of Sweden gave them a pass to go and observe the transit of Venus from the northern part of Sweden. Jesuits and other clergymen, priests and ministers, Protestant and Catholic, were collecting the data all around the world. They were the missionaries going around the world. They were the ones reporting. About 10 years ago, I was invited to give a talk in northern Wisconsin on an Indian reservation. Ironically, the guy who invited me was a fellow named Sanjay, so he was the other kind of Indian. And while I'm talking there, I was also talking with a group with an Indian elder. I gave up and gave my meteorite talk, and then the Indian elder, who was not at all elder, he was about 25 years old and looked like one of these guys from the cover of a romance magazine. And he was giving his talk with a Macintosh PowerPoint. And he was talking about his tribe's traditions and their knowledge. He was a very good speaker. He was very knowledgeable. And afterwards I said, "Where did you learn all of that? Was it passed down from your grandfather?" And he said, No, I read it all in the Jesuit Relations. The Jesuits and the other missionaries going around the world did the science of describing what were the local people like, what was the local fauna like, how did things work. They were the scientists. They were not anti-science, they were science. Just to give one final example, a personal hero, Angelo Secchi, great Italian, 1870. Angelo Secchi is working at the Roman College. Next to the Roman College, the Jesuit College in Rome, is the Church of St. Ignatius, big Jesuit church. Anybody ever been to Rome? You've been to the Church of St. Ignatius? A couple of you recognize. You'll remember this is the church that's got the weird dome. You go inside, it's kind of a dark up there, but it looks like a dome. And you walk a little bit further, and it looks like it's falling in your head. And you walk a little bit further, and you go, that's really weird. It's all painted on perspective on a flat roof because they ran out of money to build the real dome. Because they had this big building with pillars to support a dome but no dome there, Angelo Secchi puts telescopes on those pillars. But with these telescopes, he does something that nobody had ever done before. He looks at Mars. And he's not trying to figure out where is Mars so I can calculate its orbit using mathematics, which is what everybody else was doing in astronomy. He did not ask, where is Mars? He asked, what is Mars? What am I looking at on that surface? I can see that some parts of it are darker than other parts. Some parts look like channels. Some parts look like mountainous areas. And the things he calls canali are really there. They're not the canals that Percival Lowell saw 50 years later. He did something even more bizarre. He took his telescope and pointed it at a star and then put a prism into the starlight so that every dot of light became a beautiful rainbow, only there are certain colors, lines that are missing in the color, and he recorded them all by eye and hand painted them because they didn't have color photography then. And he recognized that the missing lines represent different chemical elements. So he's no longer asking where are the stars, which is what the navigators were paying the astronomers to do. He's not asking where are the stars, he's asking what are the stars. He fundamentally changes astronomy from astrometry to astrophysics. The father of astrophysics, the basis of all of the astronomy we've done ever since, done by a Jesuit priest from the roof of a church in Rome. 1870. he also studied the sun. And his idea of understanding sunspots is so great that we've got a spacecraft, NASA has a spacecraft, that's observing the sun with an instrument package called the Sun-Earth Connection Coronal and Heliospheric Investigation Package. There's fame to have NASA call an acronym for you. I'm always trying to figure out what Consolmagno would be. The completely obscure, too many letters. Fundamental physics, done by a priest in the 1870s. So, why do people think that there's a war between science and religion? Nobody's done the full-up history. This would be a phenomenal book for a historian. There's so much material. There are so many things going on. Part of it was the Enlightenment was very much anti-clerical, and they were looking for any stick they could find to beat up the church on. Part of it was the French Revolution and then revolutionary ideas. Again, the church opposed them, therefore we've got to beat up the church. Part of it was this 19th century idea, the March of Progress, the Whig idea, as they call it. Back in the old days, they thought that things were so much better in a golden age and it's all going to hell in a handbasket now. And then in the 19th century, we've got electricity, we've got steam engines. It'll only be a matter of time before we can solve all of our problems with technology. Yeah, just like World War I and World War II did. But that was the idea. And when the technologists of those days, the scientific faddists, the people who treated science not as a great way to study the universe, but as a replacement for religion, said, I can solve human problems. The problem with human problems is that there's good people and there's bad people. And if we just got rid of the bad people, then we'd only have good people. And I happen to know God has made it very easy for me to sort out the good people from the bad people. The good people look like me. And the bad people look like you. It's very easy. They developed this goofy thing they called eugenics, which eventually led to, as we know, 1930 Nazi Germany. The church was one of the few institutions to oppose eugenics. And people said, clearly the church is anti-science. There was another thing going on. In that era, at the end of the 19th century, the United States was being overrun by ignorant, stupid, foolish people with vowels at the end of their names, like Consolmagno. As part of the effort to keep immigrants out of America, Andrew Dixon White writes this book on the eternal war between science and religion. He's the guy who founded Cornell University, by the way. And his thesis was, you can't trust Catholics because they're anti-science. After all, they're the people who tried to convince Columbus that the world was flat and wouldn't let him find America. Which is, of course, if you think about it, how many people here grew up in America, you were taught as kids Christopher Columbus proved the world was round? We were all taught that. How many people, when you were a kid, were able to say, wait a minute, he didn't even make it around the world. How did he prove anything? Much less, wait a minute, the Ptolemaic system already had a round world. Everybody knew the world was round. This story is utterly, utterly bogus, but it has somehow become embedded in our educational system, in our mythology. Totally bogus. And we can identify it as books that were anti-immigrant books of the 19th century. All of these were things that led people, both in America and in Europe, to have a reason, a financial, a political reason to want to bash the church by saying the church was against science. It doesn't come with Galileo. It doesn't come even with Darwin. It comes with the politics at the end of the 19th century. And even in America, it's mostly confined, just as another example, we all know the Scopes trial, right? The fellow who wants to teach evolution and he's taken to trial. It's kind of scary if you look at the book that he was teaching from, the evolution book. I haven't read it. I read a book of a guy who did read it. He claims, when you look at the book, It uses evolution to explain why black people are inferior to white people. It uses evolution to explain why the Irish are inferior to the English. You know why the Irish are inferior to the English? All the smart Irish men become priests. Seriously, that's what they thought. This was the kind of rubbish that they were up against. In order to show that the church was not anti-science, Pope Leo XIII, when he's celebrating his ordination jubilee, has a big show in Rome and invites the priests of Italy who happen to be out in the countryside who are interested in science and technology to exhibit some of the cool things, the instruments that they've built, the science that they've done, which they do at a big show in 1887. And this makes such an impression that he asks the guy who organized it to actually found a Vatican Observatory itself, the 14th of March, 1891. That's going to be 125 years next week. That everyone might see clearly that the church and her pastors are not opposed to true and solid science, human or divine, but that they embrace it, encourage it, and promote it with the fullest possible devotion. At that time, they built telescopes on the walls of the Vatican and even had a bridge built so you could get from one telescope to the other. They had the most modern equipment of the day. One of the projects they did was to build this telescope on the left, which was a giant camera, one of 18 identical cameras sent to national observatories around the world to photograph the sky in a project called the Carte du Ciel program. That's the telescope which we still have to this day, still in pretty good operating condition for 1891. Every national observatory was given a piece of sky to photograph, and then you had to have computers, which were in those days were human beings, people who could work very patiently on tedious but painstaking work, namely women, of course. So these are the Sisters of the Child Mary measuring the photographic plates of the Vatican Observatory's section of the sky. In the process, by inviting the Vatican to be part of this program, they were de facto admitting that the Vatican city-state was independent of Italy, because Italy was also invited separately. So there's a little political game going on there, too. I'll just mention one last priest. You recognize the guy with the wild hair on the left. The guy on the right is Robert Millikan, and if you know your science, the Millikan oil drop experiment and fundamental physics that he did. This picture was taken at Caltech. The guy in the middle with the familiar collar also had an MIT, well, they didn't have a ring, they didn't have rings yet. He had an MIT degree. He had looked at Einstein's equations for general relativity and said, built into these equations is the possibility that the universe is expanding. And if the universe is expanding, then there is a time in the past when it wasn't quite so expanded. The space between the galaxy clusters was less. The energy density was therefore higher. You should be able to run the clock back to a time zero, a time that he called the cosmic seed. A fellow in England, Fred Hoyle, who hated the idea that the universe had a beginning, he thought it smacked too much of religion, made fun of this theory on the BBC and called it the Big Bang Theory. Georges Lemaitre, Father Georges Lemaitre, Catholic priest, not a Jesuit. It is possible to be smart and not be a Jesuit. Rare but possible. Is the father of the Big Bang, one of the founders of modern cosmology, and a Catholic priest. The observatory itself, when the city lights got really bad, and when we got that property back from the Italian government, moved out here to the Pope's summer home. You can see the two telescope domes there. It was opened up in 1935. Among the work we did there, besides astronomy, was fundamental work towards astronomy, measuring the spectra of pure gases. Because we were neutral territory right in the middle of a war zone, the observatory grounds were also the home to 10,000 refugees. during the invasion of Italy in 1944. After the war, Pius XII, John the 23rd came to visit the spectral lab. Paul VI, the first computer at the Vatican. And of course, the landing of men on the moon occurred on the 20th, or in Italy it was the 21st of July 1969. The Pope observed it from a television in the dome in the gardens at Castel Gandolfo and gave a pronouncement to the world over the Telstar network, so you could see television worldwide. Within 2 months after people orbiting the moon, the astronaut to the right, Frank Borman, who was Catholic, came and gave that picture he took to the head of the Vatican Observatory. And finally, we've got the wonderful picture of Paul VI himself looking through the finder scope of the telescope. He's not looking at the astronauts. No telescope would be able to do that. But a reminder that at the summertime, when the Pope was on his summer vacation, he came and visited our observatory to say hi to the astronauts on the moon. Among the things we've been doing since the mid-'80s is every 2 years we have a summer school where we invite 25 really, really promising students from around the world, students who are going to be professional astronomers. The only rule, they can be of any nationality, they can be of any religion. The only rule is we will only take 2 from any one country so that we get a wide variety of countries. It's always been the case that about 2/3 of them have come from the developing world. Since the very beginning, without having any kind of quota, it's always been the case that roughly half of them have been women. Story goes, after the first summer school, George Coyne, then the director, is called in by someone at the Vatican who's very worried. And he says, "We understand that you had students of astronomy at the summer." Well, yes, we had your permission and we had done all this. "We understand that during the summer school, the students had a party." Well, yeah, they're students, they're in their early 20s. And "we understand that at this party, there was dancing and students holding hands." Well, yes, yeah. "Were some of them women?" Yes, some of them were women. Because of the light pollution, we've since built this telescope in Arizona, as you saw in the movie. That's where it's located, in a very remote and dark spot of the sky, where you can see the Milky Way in a gorgeous... That's not a photoshopped image. The background light is because the moon has just set. The red light is because the next telescope over has a red lamp in front of the door so you can find the door. And that's the Milky Way. It's, I think, about a 5-minute exposure. I'll mention, by the way, the guy who took that photograph, who's a great collaborator of ours, a wonderful astronomer, a great friend, has given us permission to use that photograph anywhere we want to go, happens to be a ferocious atheist and terribly anti-church, but he likes us, because we're different. And that's okay, because, I only believe in one more God than he does. Beautiful mirror that we've got. We also have the meteorite lab. And we've had, you know, of course, that Pope Francis has a background as a chemist. You can tell because he brought his white lab coat when he came to visit the lab. These are the people who are, there's 11 of us now who are doing science. Rich Boyle, today's his birthday, who is on the telescope tonight observing asteroids. David Brown from New Orleans, who is in Italy, and he studies stellar clusters. There's me, there's Chris Corbally, who does stellar spectroscopy, Richard D'Souza, who's getting his degree from the Max Planck Institute, Paul Gabor, you saw in the film, Gabriele Giunti, who works in string theory. So not only is he a red-headed Italian, but he works in string theory and mathematics, which makes him impossible to understand for 4 reasons. Jean-Baptiste, who you saw in the film, Bob Mackey, who's now the new curator of meteorites, now that I'm the director, Paul Muller, who's a philosopher, and Alessandro Omizzolo, who works in quasars. We cover all of astronomy, and all of us collaborate with the other astronomers in the field. Every one of us publishes papers with people from all over the world. Rich Boyle works with a group in Latvia, in Lithuania. I work with a scientist in England and someone in Florida. Everybody has collaborators from around the world, and that means that there are hundreds of people publishing papers with the name Vatican Observatory somewhere in the author list. So why do we do it? There are a lot of wonderful phrases. This is one of my favorite from Pius XII. Man ascends to God by climbing the ladder of the universe.